Hi, I'm Miss Oliva, and I'm going to go over one-to-one functions and inverses. And this is from 3.1 if you're in my Math 161. Okay, so for a function to be one-to-one, first it needs to be a function. So remember that for something to be a function, it needs to have every x going to exactly one y. So that makes it a function. Now, if it is a function, it will then also be one-to-one if the opposite is happening, which means that every y value, which is why they're saying every element in the range, which means every y value, goes to exactly one element of the domain, which means x. So it's the exact same thing that tells us if something is a function, just with the x's and y's switched. So for something like this, if I want to know if it is one-to-one, I first need to decide if it's a function. So 13, -10, -7, -3. None of those are x's that go to one number and then a separate number. So first, is it a function? Yes. But now, is it one-to-one? I have to do the opposite. 1, -2, -4, -3. I don't have any y's that are going to more than one x. So it is one-to-one. Okay, so first, is it a function? Yes. Is it one-to-one? Yes. So how do we do that on a graph? Well, hopefully we remember that to tell if a graph is a function, we can do the vertical line test and make sure it never hits more than once. So is this graph a function? Yes. So now we can see if it's one-to-one, which means we do the opposite. To tell if every y has only one x, we would do a horizontal line test. So same idea. You need to do horizontal lines and make sure it only crosses the graph once. So this one would be a yes, it is a function, and it is one-to-one. So now how about this one? If I was trying to do this one, I'd first decide if it was a function. Right away, I can see that it is not a function. So I do not need to even think about it being one-to-one. It has to be a function to be one-to-one. So this says, use the definition of a one-to-one function to determine if the function is one-to-one. I think it's easiest, as long as you understand graphs, to think of this as a graph. So instead of doing some fancy work to try to determine this, I can just think of the fact that this is a graph. It starts at -2, goes up 2/1. It's just a normal line, right? This is a linear equation, so it's a line. All lines are functions. You're never going to cross more than once. And if I did horizontal line tests, same thing. So all lines are one-to-one except vertical and horizontal lines. Okay, so this one is a yes. Okay, same thing with number 2. I can immediately picture this, and so can you, hopefully, that this is a V because it's an absolute value graph, and it has moved 3 to the right. But it's not super important that you know where exactly these graphs are, as long as you understood that this was a line and it wasn't a vertical or horizontal line. And as long as you know this is a V graph, what's going to happen? Any V graph is going to be a function, but when you go to check, it is not one-to-one. This is another way to write one-to-one. Okay, because it did not pass the horizontal line test. Okay, so I think it's easier, even if they give you an equation, to think of what the graph looks like. Okay, number 3 is totally different. We're now talking about, are things inverses? So an inverse is basically the graph you would get if you switched all of the x's and all of the y's. which is why instead of a vertical line test, we do horizontal to find the graph that would be one-to-one. We're basically thinking about the inverse graph. So if they're giving me two equations and they're asking me, are they inverses? There's an algebraic way to determine if these are inverses of each other. So here's how you do it. And I'm just using F and G, even though we have H and K, but you'll get the idea. If you do the composition both ways, so first putting the one inside the other and then doing the opposite, if you end up getting just an X, meaning everything else ended up wiping out, then F and G are inverse functions. So in order to tell if H and K are inverse functions, I'm going to first do H of K, which means I'm going to put the K function inside the H. So I start with the H and leave that space to then put the K inside the function, which means wherever the X was, I'm now going to put all of this. So X plus 1 all over 4. So this looks way more complicated than just an X. But before you decide, really make sure you reduce as much as you can and be careful with order of operations. I cannot wipe out these ones right now because this plus one's in the middle of all this stuff happening inside this parenthesis. But I can wipe out these fours. If this 4 is being multiplied by all this stuff and the other 4 is being divided, I can reduce those, which then leaves me with X plus 1 minus 1. So now I can reduce those ones and I do get X by itself. But you cannot stop here and say, yes, they're inverses. You first have to do it the other way also. So now I'm going to do the opposite and put the H function inside the K function. So again, I'm going to start with this one so I can leave that space. So you see, I started with the K function and instead of that X, I just left a big space with a parenthesis. And now I'm going to put the H inside there. So last time when I had that parenthesis, it was very important to show that that 4 was being multiplied. This time that parenthesis didn't really do much, but I always put it there just in case. And if it doesn't do anything, then you don't have to worry about it from then on. What do I mean by it's not doing much? There's nothing outside being multiplied. There's no exponent. So really, it wasn't necessary. And I can think of this as 4x minus 1 plus 1 on top. So that means I can cross out those ones now. And now I can cross out those 4s. So now I can say they are inverses because I got X both times when I did the compositions. So this is how you tell if two functions are inverses. Okay, but now what if they only give you one function and said, please find the inverse of the other function? Well, remember, this is basically saying y, right? So y equals all of this. Well, for inverses, we always switch the x's and the y's. So the first thing I'm going to do is rewrite this problem the exact same way, except I'm going to put the x where the y was and the y where the x is. I don't move anything else. See, I didn't take the third power with the x over there, right? I left everything where it was, just switched the x and the y. And now solve for y, meaning get y by itself. So I'm going to subtract 9, divide by 7, and then do the cube root. Remember with cube roots, you do not need to do the plus and minus. That's only if it was even. So if I was doing a square root, I would now need to put the big old plus and minus outside, but I'm not. So this is my answer, but the way you'll see it written is, if the original graph we were calling n of x, then we would call this one n to the negative 1 of x, which means the inverse. So the inverse of n is the cube root of all this stuff inside. Okay, so maybe pause and try the next one, and then push play and see if I get the same thing you got. This one is going to be a little trickier because there's going to be two Y's. So you're going to have to move a lot of stuff around. So maybe start it, and if you get stuck, then push play and see how you did. So again, this is the same as Y. So now I'm going to rewrite the problem, switching where the Y's and the X's are. So anywhere there was a Y, I put X. Anywhere there was an X, I'm putting Y. And now I need to solve for Y, but this is going to be a little trickier because I have two of them. So the first thing I'm going to do is multiply both sides by that Y plus 7, so I don't have this big old fraction anymore. I'm going to go ahead and distribute that because I know I'm going to want to eventually get everything that has a Y on one side and everything else on the other side. So I'm going to move this over by subtracting. So now I would have both things that have a Y on one side, and I'm going to move this to the other side also by subtracting. So anything with a Y, I put on the left side. Anything that did not have a Y, I put on the other side, so that now I can factor that Y out, and then I'll be able to get it all by itself. You will see this concept a lot in this class and probably your next class. So if you've never seen it before, I would definitely try a couple of these to get used to it. That if you have more than one of the same letter, you're usually going to try to do this type of thing. Get each term with that letter on one side and then factor it out. So then your last step is just to divide by that extra stuff. So y equals -2 minus 7x over x minus 1. And again, the fancier way to write it instead of y is t inverse, since the original function was called t of x. This one is t inverse. Okay, I'm now going to show you one of the homeworks because it's easier to show you on Alex because it's graphing. So let me find it. Okay. So if it was asking me to graph this is kind of a review from a previous section where it's asking you to graph just part of this parabola. So remember, this is review. First, we would graph the parabola, and we know that it starts up 4 because of that plus 4. It's going to go up because there's a positive in front. And I can find my first point just by going over 1, up 1, because it's the normal shape since there's just a 1 out front. So this is the parabola x squared plus 4. But just like those piecewise functions, it only wants me to graph this where x is less than or equal to 0. So basically just this left part. So I'm going to use the scissors to cut that graph at 0, 4, because that's the middle. And then I'm going to use the eraser to erase the part we do not want. Okay. From the graph, is it 1-to-1? Well, it is a function, and it is 1-to-1 because it passes the vertical and the horizontal line test. What is the domain? We're coming from -infinity. It would normally be to +infinity, but because we cut it off at 0, I need to cut the domain off at 0. So it would be -infinity to 0 with a bracket because it was included in the graph. What is the range? The range starts at +4 and then goes up forever. So starting at 4, going to infinity, parenthesis. Write an equation for F inverse. Okay, so if we're starting with x squared plus 4, I'm going to do the same thing we did a minute ago. I'm going to switch where the X and the Y are, and then I'm going to get Y by itself. So over here, I'm going to switch where the X and the Y are, and then I'm going to get the Y by itself. We're doing the square root of both sides, so we do have a plus or minus, but since we were only looking at this graph where X is less than or equal to 0, it would be the negative square root instead of both the top and the bottom. So back to the inverse, it would be negative square root of X minus 4. Okay, so again, why was it not plus and minus? Just because of the fact in the very beginning, we only wanted where X is less than or equal to 0. So we only needed the negative part. Now it wants me to graph both parts. So how would I graph negative square root of X minus 4? It's going to be the square root function. It's going to start to the right 4, and it's going to go down. I thought it was going to ask me to, I'm going to do that again. Starting at 4, going down, but specifically going down over 1, down 1. And you can see this is what inverses should look like. They should look like they've been flipped over the line y equals x, because we're switching all y's and x's. Do you see how the one on the left starts at 0, 4, but the other graph starts at 4, 0? The x's and y's are all switching to make this graph. And so the domain, I can just look at this picture, but even if I didn't have the picture, I would already know it, because the domains and the ranges also flip with inverses. So whatever my domain was before will be my range for the inverse. Whatever my range was before will be my domain for the inverse. So it should be 4 to infinity. And looking at the picture, you can see that's true. Starting at 4, going to the right forever. So 4 to infinity. And so the range of the inverse should be the same as the domain of the original function. So negative infinity to 0. And again, looking at the graph, you can see that yes, it's coming from the bottom, so from negative infinity and stopping at 0. Okay, I just wanted to show you that one and also remind you how to graph stuff like this where you need to erase some of it. So remember to use those scissors, put in the point where you want to cut it off, and then just erase the half that you don't need. Okay, back to the notes for the last one, which is a word problem. As always. So here's one similar to what you'll find in the homework. So based on data from recent hurricanes, the function defined by W of x equals negative 1.15x plus 1420 gives the wind speed, so that's what this means, based on the barometric pressure, which is what this means. So W of x, again, is kind of like our y. So wind speed is the y, barometric pressure is the x. Approximate the wind speed for a hurricane with a barometric pressure. So they're giving us the x. The wind speed for a hurricane with a barometric pressure of 1,000 is what? So we just need to go to our equation and plug in 1,000. If they ever give you the x and want to know the y, which is basically what that's asking, you just plug in the x and solve. So I'm multiplying and then adding the 1420 to get 270 miles per hour. Write a function representing the inverse of W and interpret its meaning. So I'm going to go back up to the original. I'm going to use X and Y for now, and then we'll come back to this W, just like we've been doing. So if this was the original problem, I'm putting the Y in instead of the W of X, make it less fancy. So now I can definitely see where I want to switch things. So we're doing the same thing we've been doing, switching the X and the Y, and now getting the Y by itself. So I need to subtract this to the other side. And then finally divide. So Y equals this, which is the same as saying W inverse equals this. Okay. And what is that going to give us? It's going to give us the barometric pressure for the given wind speed. Because the original did the opposite. It gave us the wind speed given the barometric pressure. So now this one does the opposite. And that is it for inverses and one-to-one functions.